would like to welcome you all on behalf of the Doble Engineering Company. In this presentation, I'll introduce the Doble's state-of-the-art instrument F6000 power system simulators. This presentation is in two parts. The first part covers an introduction and hardware feature of Doble's F6000 power system simulators. The second part covers the application of the test instruments for testing different protection systems, as well as the introduction to Protection Suite software system and other members of the F6000 family of power system simulators. The base model of the F6000 family of power system simulators is F6150. I'll cover the features of this model in Part 1 of this presentation. The Doble Engineering Company is the pioneer in providing protection test instruments since 1970 and has over 10,000 protection test instruments which provide satisfactory service to electric utilities worldwide. Continuing a tradition of quality and new levels of analytical capability, the Doble Engineering Company has developed the latest state-of-the-art protection test instruments called the F6000 series of power system simulators. Doble's design of the F6000 family employs state-of-the-art DSP technology in signal generation and control. This technology is combined with an innovative switching power amplifiers design which results in a compact yet powerful instrument that caters to the electric utilities' all protection and meter testing needs. The test instrument F6150, a member of the F6000 family, is the single box solution for your entire protection system's testing needs. Since the introduction of the power system simulator F6150 in 1999, Doble is in sync with the technology evolution. We continually add advanced features to the instruments to benefit the testing community. As the protection system advances, we add features to the F6150 to advance the product spec. A high-power option allows engineers to test the complete protection scheme, which may include a backup high-burden electromechanical scheme. Highly accurate voltage and current sources, coupled with easy-to-use metering test module, allows you to test transducers, energy meters, as well as revenue meters. A built-in Ethernet switch allows users to test IE61850 protections easily. The fiber optic communication connector allows users to test the numerical protection that employs sample value IEC61859-2 functionality. Our wireless Wi-Fi Ethernet adapter allows users to test the protection in a tight space, eliminating the need for a computer to be placed next to the test instrument. The PC software program designed to control the F6150, called Protection Suite, is a user-friendly program that requires a very short learning cycle. The user interface layout is very intuitive. It's divided into four major parts: analog sources and battery simulator interface, logic input and output interface, DC meter transducer interface, and communication ports. It has an interface area for GPS synchronization as well as additional logic I/O and low-level sources. F6150 has a built-in display which enables users to identify information like firmware versions, IP addresses for communication, as well as the options installed on the instrument. When the test is in progress, the same display indicates the status of the sources, logic inputs and outputs, and provides an alternate way to communicate with the operators other than the computer screen. The flexible design of this instrument provides configurable sources for up to 6 voltages and 6 currents along with 8 inputs and 8 outputs. This enables you to test all types of protection. It provides multiple sources to test numerical protection, and also the sources can be combined to provide the higher power required to test high-burden electromechanical relays. This is possible as the F6150 employs innovative switching power amplifiers, which provides compact yet powerful high-power sources. A block diagram of the switching power amplifier is shown here. Line input charge capacitor to 350 volts DC. Two inverter circuits converts DC input to high-frequency AC signal. This signal is then fed into transformers, which in turn drive four synchronous rectifiers. The output of these synchronous rectifiers is then fed into the range selection circuit. The relay switch matrix generates the desired output. It generates two sources or one source depending on the setting. This design makes the source output independent of any variations in the line input. Also, switching power amplifier technology delivers high power continuously in a compact design without overheating. The switching amplifier design of the F6150 provides independent control of the source magnitude, phase angle, and frequency. The most important thing to remember here is that the source output is independent of the relative position of other phases. This is not the case for most of the instruments currently on the market. The F6150 standard current source has a 150 VA output rating and provides 7.5, 15, and 30 amps AC or 5, 10, and 20 amps DC current ranges. When used in a high-power mode called transient mode, the current source provides 150% of rated power for 1.5 seconds. In this mode, the current range is twice the normal range. The transient mode is very useful when high power and high current is required for short durations, like testing instantaneous over current protection, which may be 15 to 20 times the relay tap setting. The construction of the instrument is modular. Each module is calibrated separately. The design provides redundancy and ease of maintenance. In case one of the amplifier fails, the diagnostic routine will indicate this and the user can remove the defective amplifier. The instrument is still functioning and can be used when one or more amplifiers are missing. Though it will have reduced functionality, the instrument is usable. Once the replacement amplifier is installed, you can start working without the need for recalibration. Built-in redundancy and modularity provides easier maintenance and improved productivity. F6150 is the base model for the F6000 family and provides three 150 VA voltage sources. These sources can be converted into current sources to provide a high-power, low-range current source for testing. I'll talk more about that later in this presentation. It also provides 150 VA current sources which can be combined or split through software control. Three 100 VA current sources can be combined as one 450 VA source or can be divided into six 75 VA sources. This provides maximum test flexibility and allows you to test all types of protection with only one instrument. The F6150 provides 8 isolated logic inputs and outputs. Inputs can be programmed in the field as contact sense or voltage sense. Logic inputs are used to sense the relay response for timing, pickup, or dropout tests. 8 logic outputs can be configured as normally as open or normally closed contacts. Outputs are used to simulate power system events like carrier received, auto reclose block, and breaker position. 8 inputs and 8 outputs can be extended to 16 inputs and 16 outputs by using an external box. A built-in battery simulator can be used to power numerical protection. Its output is 0 to 300 volts at 90 watts. This is very useful when testing protection schemes in the field if a battery supply is not available. The F6150 PC is controlled via a USB or Ethernet port. The fiber optic Ethernet port enables users to test IE61850 sample value feature. The wireless Ethernet port is also very useful in a tight space where physical connection between a PC and the instrument may be inconvenient. It allows for a PC to be at a more convenient and safer location for the user during the test, and hence increases the productivity of the testing personnel. The instrument provides a facility to synchronize its sources to GPS, 1 PPS signal. This allows multiple F6150s to synchronize to a common reference signal for end-to-end tests without the need for networking. The low-level voltage outputs allow testing for a special protection scheme with a Rakowski coil or intelligent circuit switchers. A 150 VA current source provides a 7.5, 15, and 30 amp user selectable range. When used in a transient mode, it provides 50% more power for 1.5 seconds. In this mode, the current range is 15, 30, and 60 amps. One big advantage of multiple current ranges is that the source provides more output compared to one wide-range current source of the same rating. By series or paralleling the sources, F6150 provides wide current ranges of 7.5 to 180 amps. The shaded area shows the power output versus current for a 7.5 amp range for 150 VA current sources. Here, the black shaded area shows the power output for a 15 amp range for a 150 VA source. Now, let's say we have one source of 150 VA with one current range of 30 amps. As mentioned, the black shaded area shows the power output for a 30 amp range for a 150 VA source. The compliance voltage for this range is only 5 volts. At 5 amps, the power output is 25 VA, while the power output is 100 VA for the source with the same power for the range of 7.5 amps. So having multiple ranges is very useful as it provides more power output from the source. As I said earlier, the F6150 voltage source is convertible and can be configured by the user as either a voltage or current source. In voltage mode, the source ranges are 75, 150, and 300 volts AC. The voltage source when used in a current mode provides low-range current output at high compliance voltages. The current ranges are 0.5, 1, and 2 amps for 150 VA sources at compliance voltages of 300, 150, and 75 VAC. The low current range at high power is very useful in testing high impedance protection like time over current ground protection or high impedance bus bar protection. So let's go through a sample calculation to show why we need high power at low current outputs when testing electromechanical ground over current relays. Consider a ground over current relay set at 0.2 amp, where the typical burden of such types relays is 3 VA. If the burden is 3 VA at a current setting of 0.2 amp, the impedance it offers at this point is 75 ohms. So if you want to test this over current relay at 5 times the setting, i.e. 1 amp, the power required is 75 VA. Similarly, for testing the same relay at 10 times the setting, i.e. 2 amps, the power required is 300 VA. F6150 is the only test instrument on the market that provides such high power at low current ranges. As discussed earlier, all the sources of F6150 can be connected in series or parallel. By paralleling 2 convertible current sources, you can get the range of 1, 2, or 4 amps at 300 VA. Similarly, 3 current sources can be paralleled if higher currents and high power are required for testing high impedance protection. The F6150 is the only instrument on the market today that provides such flexibility. The F6150 instrument provides the facilities to series or parallel the sources. This covers almost all combinations of test conditions for the user. The series and paralleling of sources is done internally through software control and externally by proper connections. Connecting the sources in a series provides more power at the same current, while paralleling of sources allows protection testing at high power and high current. In addition, as pointed out earlier, 150 VA voltage and current sources can be configured as two 75 VA sources provide even more testing flexibility. It is possible to configure three 150 VA current sources as 6 sources for testing a 3-phase numerical current differential protection scheme. By installing an E option for current sources, you can get a higher power and higher current range. The E option, also called Enhanced Rating, provides the current ranges of 8.75, 17.5, and 35 amps at 175 VA. This source also provides 50% more power at twice the current range for each source of an extended period of time. By combining 3 sources in a series or parallel, you can get a wide current range of 8.75 to 210 amps. Let's discuss the different models available for the F6000 family of power system simulators. The F6150 SV model is ideal for testing IEC 61850 protection, as well as protections that require high power and high current. It provides optional features such as enhanced rating current amplifiers, IEC 61850 sample value and goose testing functionality, as well as Wi-Fi communication. Both copper and fiber optic ports for IEC 61850 sample value testing are inbuilt. The F6150 SV also has a wireless Ethernet port for additional test flexibility. The F6150E is the available model for testing conventional protection. It provides enhanced rating current amplifiers and Wi-Fi modules as optional add-ons. Sometimes when you want to test a complete panel with primary and backup, you may need high-power, high-current sources. For such a test, Doble provides the F6300E instrument. When used with the F6150E or F6150SV, it can provide 3 high-power current source of 788 VA each and delivers a current up to 210 amps. When used with the F6150SV or F6150E, the F6300E is capable of providing 9 current sources each up to 70 amps, allowing you to test 3 Phase 3 winding transformer differential relays. One more model is available, and it's the F6350E. This is very useful when you want to do a real-time digital simulation of the power system events. This visual shows an application of the F6350E, which can be used with a real-time digital simulator to check the behavior of a protection system by simulating a series of power system events. In this case, the F6350E simply provides high power current and voltage sources as slave amplifiers. This concludes the first part of my presentation. The salient points that I discussed are as follows. The F6150 employs a state-of-the-art switching power amplifier technology which provides a compact design to deliver high power independent of other sources. It also delivers a full power output without overheating. These are the 2 main advantages of switching power amplifiers. Multiple current ranges employed here provide more overall power over the entire range compared to a single range instrument of the same power. A voltage source that is convertible to a low-range, high-power current source allows you to test high-burden protection. The F6150 is the only instrument on the market capable of testing low-set, high-burden protection. Highly accurate sources allow you to test PMU as well as energy meters in addition to test protection schemes. 3 models allow you to choose the model best suited for your application. The model can be upgraded in the future to protect the investment in case the test requirements change. Wi-Fi and enhanced current amplifiers are optional features for the F6150E and can be added in the future if the requirements changes. This provides you an economical solution to fit with your testing needs. The rugged design of the instrument makes it suitable for field use. The modular construction provides for redundancy and improved productivity, as a module can be replaced in the field in case of a failure. The replaced amplifier does not require you to recalibrate the instrument. Thank you for listening. If you have any questions or need more information, please don't hesitate to contact your local Doble channel partner, our area sales manager, or contact Doble directly at www.doble.com.